Welcome everyone, I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 40, which is combination sum 2. Let's see the problem description. Given a collection of candidate numbers, candidates and target number target, find all unique combinations in candidates where the candidate number sum to target. Each number in candidates may only be used once in the combination, and note that the solution set must not contain duplicate combination. So we do not have to push the same elements again and again. Like if we already pushed like 116, we do not have to push 161 again because it is the same if we sort the values. So we do not need to push that again. And let's see the constants. The length of the candidates will be up to 100, and each of the elements of candidates will be up to 50, and target is 1 to 30. So let me discuss the algorithm with you. So to solve this problem, we will use backtracking, and because we do not need the we need unique combination, we do not need the duplicates. So first we need to sort the given candidates array. Okay, and we will use a current array to which will keep track all the elements we currently visited to achieve the target sum. And we do not add the same element, if there is 3 times 5, we do not add multiple 5 at the same position of the current array. Okay, let's say current array, or already pushed 2 elements in the current array, and now the time comes to add the third element. We do not add same values in that position. Okay, so we will see the code, then you can understand that. So first we will need the answer. So answer, let's say, and let's say current vector is current, and need to sort the candidates. So candidates dot begin and candidates dot end, and we will call a recursion function which is, let's say, helper. We need answer, the current, the candidates, the target, and current index which is 0, and let's say the size of the candidates, let's say, which is current candidates dot size, and after that we need to return the answer. Now let's make the helper function. The return type will be void, and the parameters are: first is answer, second is the current element, third is candidates, fourth one is the target. I'm putting it as T, and then we need the index is I, and the length is N. So first we need to check if the, let's say, target is equal to 0 or not. If it is 0, then we need to push the current array, like current visited, what the element we have visited to achieve the sum. So answer dot pushback, the current will keep track all the elements that we currently visited to achieve the sum. And one last thing, we need to make it as reference, because if we change anything, if we push anything in the answer, and we need any of the function call stack, we want to reflect that in all the actual, this is the actual instance, we need to uh, add the reference so that all the pushed like elements reflect on the actual values also. So this is, and after that, for all the elements int j equal to I and j less than n, j plus plus. For all the remaining element, we will push all the elements, like we will keep it or we will do not keep it. So to keep it, first we need to check if we can like keep it in the current stream. So if j candidates j is greater than target, then we can't put it like in the current stream. So just break the for loop, because if we can't put the current element, then as it is sorted, we can't put the rest of the elements also. So better than like break it, so that we do not need to visit the other elements also. And if we can keep it, so first keep like push it to the current stream. So push back candidates of j. Now the current position is, we already put that current element, and now we need to find the other elements also. So our recursion function will do that. So let's say helper and answer the current, now the candidates. Now the target will be target minus, we already pushed the candidates current element, which is a candidates j. So we need to subtract that from the target, and second thing will be j plus 1 will be the next index, and n is n. Okay, which will push it all the possible combinations to the answer after adding the current element. And this is the condition for adding the current element. And you also need to check the, not if we do not add the current element, to check that we need to pop it current dot pop back, and after that we will check for other elements also. So just pop back, that's it. Let's see if we will work on that. But there is a problem, because we are not like actually this wants the do not want the duplicate one, wants the unique ones. So we need to, like if we the already added the one element at the current position, we do not need to add the same element again. So we need while j plus 1 less than n, and candidates of j plus 1 is equal to candidates of j will add j plus plus, so that all the same element, because if as the array is already sorted, so all the same values element will be consecutive. So we will just skip that part, and next we will check that for rest of the elements. Okay, let's see will it work or not. So it is accepted, let's submit it. Let me discuss the time and space complexities. So the time complexity for this recursion function, we are checking for each of the element all the possible combination after that. So if you draw the recursion tree, you can see, like for example, the current elements is a and the next element is b. So we can add it the current element, let's say we can add the a, or we can't add the a in the current tree. So there is two possibilities, and for each of the possibilities, the second element, let's say b. So for we can also add the b, or we can't add the b for each of the current elements possible. So if you draw the recursion tree, you will see the recursion tree grows exponentially. So the overall time complexity for this recursion function will be 2 to the power n, where n is the length of the candidates. And to sort these elements, it will take big of n log n time, where n is the length of candidates. So Overall time complexity to solve this problem will be 2 to the power n. Okay. And the space complexities will be, we are finding for all possible unique combinations. So in worst case, there would be all possible combinations of candidates, which will take up to the all the possible combination will be up to 2 to the power n, and for each of the combination, it will take up to the n length. Okay, n where n is the length of candidates. So overall space complexities will be 2 to the power n into n. Okay, where n is the length of candidates. And you might wonder, like, if the time complexity is 2 to the power n, how the question already accepted? Because here length is 100, so 2 to the power 100 is huge number. Because there is the target is very less. Target is 30, and all the values are from 1 to 50. So the in any at any case that if the current element is greater than t, t is the remaining target, so it will break down, so it will not call the recursion function again and again. Okay, so we can get the up to 30. In worst case, the target is 30, we could get 30 up to adding n elements, where n will be 1. Okay, n elements mean 30 element, we can get 30 by adding 30 ones. Okay, so the this recursion function won't take like 2 to the power n, because the target is very less. It will after eventually it will break down because the target is very less. So that's why this question is accepted, even if it is takes like 2 to the power n time curves, but we can see the constant is, so that we can analyze the algorithm. Thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.